In 7.4, we're going to be learning two terms. The terms you're expected to know in 7.4 are the angle of elevation and the angle of depression. When we say that something's angle of elevation is, or something's angle of depression is, we are going to assume that you know that it's always measured from horizontal or from level. When you are doing these problems, make sure you know it doesn't matter whether we're talking about elevation or depression, but they are always from level either up or from level down. Angle of elevations and depressions are always from horizontal, and they are always congruent by the alternate interior angles theorem. So let's talk about what this looks like and how problems are. The angle of elevation of the dog to the bird is measured from horizontal. So I'm going to put a little dotted line like this. That dotted line, that's level. That's from horizontal. Angle of elevation is measured from horizontal up. So where we put the angle, it has to be right here. This is the angle of elevation. The angle of depression is from the bird to the dog. So from level downward is the angle of depression. These two angles are going to be congruent to each other. They're not necessarily, they are congruent to each other because these two horizontal lines are parallel to each other. And that goes right back to what you learned in Advanced Math 8, Honors Math, Regular Math 1, where you learned alternate interior angles are congruent every single time. The other thing is that I want you to know it's just a matter of perspective. Let me draw a little ant right here, or a bug. And here's my little bug or a spider or whatever, what have you, okay? There's a spider right here. And it's crawling on the ground. This dog has an angle of elevation up to the bird, but if I were to think about the dog to the spider, that would be the angle of depression. Because from horizontal downward, it just depends on your perspective. On your worksheet today, you are going to have several examples that are going to say, well, what is it from the boat to a submarine or from the submarine to the boat? It just depends where you are. If you're below it and you're looking up, it's an angle of elevation. If you are above it and you're looking downward, that is an angle of depression. You're going to be expected to know that. Pretty simple stuff. Now, this angle of depression up here, is that going to be congruent to this angle of depression here? Not necessarily, because the distances are farther or closer together, so that would change the angles. Okay? Most of the problems that you have today on 7.4 are going to be dealing with word problems. So that is what this next little line says. You will use what you learned in 7.3a and 7.3b to solve problems in 7.4. Meaning, now that you know how to do SOHCAHTOA, you should be able to handle these problems. We're only going to throw some words in there for angle of elevation and angle of depression. Okay? So, that is it for our notes. If you would like to do this over in your packet, you are welcome to do so. This is number 7 in your packet. And I have already started the picture for you. A person is standing 40 feet from a flagpole and can see the top of the pole at a 35-degree angle of elevation. The person's eye level is 4 feet from the ground. What is the height of the flagpole to the nearest foot? So I have a person drawn. I have a flagpole there. And I did this from eye level. Is it from the person's feet? Is that where the angle of elevation is? No. It's always from level, from where the eye is. They're measuring up using their eye, and they're using level as their base. So I'm going to start putting in some values into this particular triangle. The person is standing 40 feet from a flagpole. What is that? Where does it go? I would put it right here. From the person to the flagpole, 40 feet. It's always measured as a perpendicular distance, so we should know that as well. And you can see the top of the flagpole at a 35-degree angle of elevation. What does that mean? That means from horizontal up. .35 degrees goes there. The person's eye level is 4 feet from the ground. So that must mean that from here to here is 4 feet. And what that also means is that from here to here is 4 feet, right? If we're talking about level. The question says, what is the height of the flagpole to the nearest foot? So if I'm using this triangle, I'll only find the height of the flagpole to right about eye level, but I'm going to have to add the 4 feet to it, aren't I? Like my goal will be to figure out this whole thing. Okay, so now that I have my picture drawn, I'm going to set up the my equation. What I would recommend you do first is the first thing that we always do. We highlight the angle. And then we have to label it. Oh, ha! You remember that? I don't know if you guys laughed. I'm curious. Did you guys like that when I did it in the video? Okay. I was just wondering. I had fun saying it. I'll be honest with you. I thoroughly enjoyed it. And I was by myself. But if you cannot laugh by yourself, then I don't know. You're going through life too serious. I'm going to label this O and A because I have an opposite and adjacent. I don't have a hypotenuse. I automatically know which trig function I am going to use. If you know what trig function you're going to use, tell the person you're sitting next to, please. I heard several of you say tangent. Good. I would recommend tangent of what angle? Don't forget the angle. 35 degrees is equal to the opposite, we'll call it x, over the adjacent, which is 40. That's really not what we're looking for. I'm going to figure out what x is. I'm going to times by 40 and times by 40. And I have 40 tangent of 35 degrees equals x. Is that going to be the height of the flagpole?
No.
What else do I need to do?
Plus 4.
Plus 4 to that to figure out what the height is. So before I even grab a calculator, I am of the type of person that will always write down what is it I need to find first. Write down the whole thing that I'm going to plug into the calculator, and after correcting most of your homework, I can tell you some of you need to start writing down your equations. If you mess up, you get 0 points partial credit unless you write this stuff down. I'm going to look over at somebody right now. Yes. Okay. Because I see answers on the homework, and I know you're getting those answers by plugging in equations, but if you don't write this down, you will never get partial credit in my class. Make sure you write it down. That way I go, oh, they used the correct numbers, they forgot to multiply, they're dividing. I can see where your mistake is. You can get up to half the points for just writing this down. Okay? Equals the height. Let's do that. Let's call that the height. Get my calculator. Making sure I'm in degrees, which I am. 4 tangent of 35 plus 4. Let's see if you're getting it to the nearest foot. If you got 32 feet, please raise your hand. I can see how many of you already did it. Wonderful. Simple. The other example that I chose to do with you is number 10. And this will be our last example, and then we'll take a little bit of a break. An airplane is flying at an altitude of 10,000 feet. The airport at which it is scheduled to land is 50 miles away. Find the average angle at which the airplane must descend for landing. So I got my airplane there. It's already drawn. And I started with this red line and this other red line, and one's a lot longer than the other because I know that 50 miles away is a lot longer than 10,000 feet. And then I noticed something, that this one is measured in feet and this one's measured in miles. We're going to have to convert. This is 10,000 feet. It's flying at 10,000 feet. And then we have 50 miles, but I'm going to put the 50 miles right about here. 50 miles. 50 miles away. But that's not in feet, so I need it to be in feet. So let's see, miles, miles, and then I need feet. If I want to multiply it by something, miles, miles will need to cancel, and how many feet are in a mile? I know how many. There's 5,280 feet per mile, which means if I multiply 50 times 5,280, I'll know exactly how many feet that is. It's 264,000 feet away. You could convert this into miles if you wanted to. As long as you're in the same units, then you'll be able to set up your triangles. The airport is scheduled round. Find the angle, average angle at which the plane must descend. Now, what does that mean? That means that if I think about it, what we're trying to find is the angle of depression. We're trying to find this. And earlier, I told you that the angle of depression is congruent to the angle of elevation. So I can put the x there, and I can put the 10,000 over here, but a lot of times I'll just put the x in the same spot because they're congruent to each other by alternate interior angles. In this particular case, if this is my highlighted angle, then I have an opposite and I have an adjacent. Do you know which trig function you're going to use? I hope you're going to use tangent of what angle? We don't know. X degrees equals the opposite, 10,000, over the adjacent, 264,000. If you want to figure out what x is, then what you're going to need to do is to get rid of this tangent, which is trapping that angle, by doing the inverse tangent of that whole thing. So what I'm going to type into my calculator, and feel free, let me see, just to make it easier on myself. I'm going to type in the inverse tan of 10 divided by 264. To the nearest degree. 2.169 is about a 2-degree angle of descent. Any questions? Ethan?
When you're rounding the angles, you just go to the whole number?
Just depends on what the problem says. I always read the problem, what does it want me to go to? Some of them are the nearest tenth, some say the nearest degree. Okay? Anything else?